we would like to find the image of the line real part of z plus imaginary part of z equals 1 under the reciprocal mapping f of z equals 1 over z. So the variable z is x plus iy. So the real part of z is x, and the imaginary part of z is y. So this equation corresponds to the equation x plus y is equal to 1, which is a line in the xy plane, or in the complex plane, through 1 here and I here. So those are the points that have x plus y equal to 1. Y is equal to 1 minus x, so the slope is -1 and the y-intercept is 1. Okay, so f of z is 1 over z. That means if we use the complex variable w to represent f of z, then w is going to be u plus iv. And if w equals 1 over z, then we can say that z is equal to 1 over w. And this is the best way to approach the mapping properties of 1 over z. So x plus iy is equal to 1 over u plus iv. Now, the reciprocal is, since w times w bar is equal to the modulus of w squared, we can see that w is equal to modulus of w squared over w bar, which means 1 over w is w bar over modulus of w squared. So here's our w, it's u plus iv. 1 over w is what we have here. 1 over w is w bar, u minus iv, divided by modulus of w squared. Now the modulus of w involves a square root, so the square will just cancel that square root. The modulus of w squared will be u squared plus v squared. So x, the real part, is equal to the real part on the right side. That's u over u squared plus v squared. And y, the imaginary part, is equal to the imaginary part on the right side, which is negative v over u squared plus v squared. Now our line has x plus y equal to 1. X plus y equals 1. So if we add these two right sides, they add to 1. U over u squared plus v squared plus negative v over u squared plus v squared is equal to 1. Which is, we can just combine these fractions. They have the same denominator. U minus v over u squared plus v squared is equal to 1. Now this represents a curve in the uv plane. So let's figure out which curve. We'll multiply both sides by u squared plus v squared. So u squared plus v squared is equal to u minus v. And putting everything on the left side, u squared minus u plus v squared plus v is equal to 0. And now we will complete the square. Complete the squares here. You take half of the coefficient of the linear term and then square it and add it on. So u squared minus u plus half of 1 is a half, and then square that. So we would have minus a half technically because that's minus 1. So half of that is minus a half. Square that, and that makes 1/4. So that will complete the square. This is now a perfect square. And we do the same thing with the v. V squared plus 1/2 squared is also 1/4. So we're going to add 1/4 here as well. And we added 1/4 to both sides. So instead of 0 here, what we have is 1/4 plus 1/4. Now let's write this as a square. This is u minus 1/2 quantity squared. And this one is v plus 1/2 quantity squared. And the right side is 2/4, which is a half. So this is an equation of a circle in the UV plane with center at the point 1/2 comma negative 1/2 and radius the square root of 1/2, which is also 1 over the square root of 2, or the square root of 2 over 2. So that will be our image. It'll be this circle. So let's put this together. Our line is x plus y equals 1 in the z-plane. And then when we figure out the image under the reciprocal transformation, we get a circle in the UV plane whose center is at 1/2 comma negative 1/2 and whose radius is 1 over the square root of 2. So this distance here, this point is 1/2, this center point is 1/2 minus 1/2 I, and the distance between here and the origin is exactly this radius. So we have, this is our radius here. So our circle looks something like, the circle looks something like this, except for we're supposed to have a circle. So that's the image. Some more details here, because actually the mapping f of z equals 1 over z, or w equals 1 over z, if we put infinity in for z, then we get w equals 0. So the image, the output when you plug infinity in is 0. And we get infinity here at both ends of the line. So as we travel along this line, heading towards infinity, the image should approach 0. So as the modulus of z goes to infinity, the modulus of w should go to 0, which means that w itself goes to 0. So this point, which I've emphasized here, should really be an open dot. It's not actually part of the image because these lines never actually include the point infinity, so their image does not include the point 0. So let's look at some more detail here. Let's take this point right there, the point on the line y equals x. So that's the point where x and y are both a half. 1/2 plus 1/2 I. And let's find the image of that. So f of the point 1/2 plus 1/2 I is 1 over that point. And we can factor the 1/2 out. 1 over a half is 2. and we're left with 1 plus I. And then 1 over 1 plus I would be 1 plus I bar divided by the modulus of 1 plus I squared. And this is 2 times this conjugate is 1 minus I, and this modulus is the square root of 2, so squaring it gives us 2, and the 2's cancel. And so the image of this point is the point 1 minus I, which is on the line y equals negative x. So it's on this line here, 45-degree line. There's the point 1 minus I. So this point. Now, where does the point 1 map? So let's put 1 in red. Well, 1 over 1 is 1. So this here must be the real number 1. And what about I? Let's put that one in green just for fun. There's I. 1 over I is negative I. Check it. Negative I times I is 1. So 1 over I is negative I. So the image of this point is negative I, which is here. So what's happening in this transformation is, so the blue dot here maps to the blue dot there, which kind of, between the blue dot and the open circle here, we have a diameter. So, and this blue dot here in the domain also kind of symmetrically divides this line with respect to the axes. We have the symmetry there. So this ray is going to map to this circular arc, and as the z here goes off to infinity, the 1 over z will head towards 0. So this arrowhead on the ray corresponds to this arrowhead on the circular arc. And then on the other side, this ray will map to this semicircular arc right there. So the image of this line is this circle. Well, it's not quite a circle. It's a circle with a point missing. And that point corresponds to plugging infinity in the domain. But that's, of course, an issue. So that point is not in the image.